Okay, so let's try to solve a trig equation quick because, there are hang-ups and we should be aware of them. So let's say we want to solve 2 cosine of theta is square root of 3. How many solutions is this going to have?
Well, plus or minus that thing.
You don't have that because that's already
You didn't
there.
make
You
it,
didn't
yeah.
make it, so it's not fine.
Oh, shit. Okay, so should we try this graphically first? Okay, so what's 2 cosine of theta look like graphically?
It's a sine wave, but the peak is at 0.
It's a cosine wave.
It's a sine wave, but the peak is at 0. Or it's a cosine? Yes. No, that was good. Okay, so
cosine 2 is anyway.
cosine looks something like this, right? How high are these?
1.
Yeah, normally they're 1 and 1, but I'm talking about 2 cosine theta, right? So these are going to be at 2 and minus 2. And these dudes?
Period's still the same. So it's going to go after 2.
Period's still the same, so that one's a pi over 2, a pi, a 3 pi over 2, and a 2 pi for the top there. You guys all good with this? Okay. Where's square root of 3?
Well,
Is that somewhere
a
between
little
1
less
and 2?
than 2.
Okay, square root of 3 is, why is square root of 3 smaller than 2?
Because
That's
otherwise
why
it's
Four
like
is
triangle.
2.
Good, because the square root of 4 is 2, and square root is a increasing function or something. Or something. So square root of 3 maybe is someplace in here, right? You guys see that? So really, if I was doing a good job with this, I'd be saying something like this, right?
There's a lot of square root of
Yeah, there's going to be lots of solutions. This is going to be true every time you set a trig function equal to a value, right? You guys see that? There's either going to be crap loads of solutions, right? Infinitely many, or none at all. Can you guys come up with an equation that would have none at all?
equals 4.
Yeah, or equals
2
anything
cosine
more
equals
than
2
2.
or anything more than
Yeah,
2.
so 2 cosine theta equals
7.
7, 37,
3.
right? 3.
2.0.
Yeah, any place where I'm drawing that line up here, right? There's not going to be any solutions because that line would never hit this oscillating wave. You guys see that? So anytime it actually hits, though, there's going to be lots of solutions. How do I find them all? How do I find one?
If your graph is like pretty accurate, you can kind of rough estimate.
Okay, good. You can get rough estimates off the graph as long as you do a nice job. That's actually what a computer does.
Well, if you cut the domain, then you can solve for the angle that one cosine is square root of 3, right?
Okay, so let me kind of slice the domain per usual, right? He's smart. For real.
I was just like, why are you trying to make my work for us?
No, that's how you do it. So take this thing. What's your first step going to be? You're going to divide by 2, right?
Yeah.
So we'll multiply by half. So we get cosine of theta is the square root of 3 over 2, right? Then we'll hit both sides with a cosine inverse, right? Which isn't actually an inverse function. You guys see that? So this is a step about which I should be extremely concerned. Cool? So I'm going to get theta-ish, right? Equals cosine inverse of square root of 3 over 2. Okay, so do you know an angle where the cosine is root 3 over 2?
Yes.
But do you know a triangle with root 3's and 2's in it?
Yeah.
Yeah, the 16.
Oops. This is a crap triangle for the one I was trying to go for.
That's all right. Just, you can just plug it in. No, God damn it.
Pi over cosine 6.
See, so I'm looking for the equilateral triangle cut in half, right? So it's going to look something like this. This one's 2. This is pi over 3. and this is pi over
Six.
6. And what else do I know?
1
1 and square root of 3. Cool. Okay, so where's the cosine root 3 over 2?
That would be a
30 pi over, pi over 3.
Pi over
Sorry, pi over
6, right? Because cosine's the adjacent side. So I'm kind of thinking, okay, theta-ish is pi over 6. Yeah, but so that was when I did cosine inverse to both sides, right? But cosine inverse cuts this whole picture, right? It cuts it to just in here. You guys see that? So to find this intersection here, I found that happens at pi over 6, which means my picture is for crap, right? So that point there is pi over 6, comma, I don't freaking know. Wait, I do know. Where does that happen? What's the height there? Perfect. Good, that's root 3. How do I know the y is root 3? Because that's where it hits this thing, right? You guys see that?
So
Okay, so
doing an inverse of like anything restricts it to 0 to pi.
not of anything, the cosine inverse function, right? I cut at 0 to pi to keep it 1 to 1, right? But when I did the sine inverse function, I cut it at minus pi over 2 to pi over 2. So this is why you have to be careful, right?
Because you're just trying
Because
to
the
find
graph
where
is
it's
shifting.
covering the whole length of it, not necessarily like just one thing, because you don't want it to hit twice. You want it to only hit once and cover the whole thing.
Yeah. I want it to kind of be the area around 0, right? Or as close to 0 as possible, where it's 1 to 1. And so on this one, I had to cut at 0, and I got to go up to pi before I had problems. On sine, I had different problems, so I cut in different places.
So if you got here, could they throw like polar stuff at you?
What?
Could you give it an angle and a length?
Oh, yeah, sure, we could do polar things. I don't want to do polar things, because right now I just want to solve this damn
I was
equation.
just wondering if, like, that could be like a possibility of things that people
I personally probably wouldn't write a problem that tangled these two things. Life might, but I probably wouldn't. So I have so far one answer for theta, right? Pi over 6. There are supposed to be infinitely many answers. How do I find the rest?
Multiply by 2 pi.
Not
Well, 2
multiply
pi
by
would
2
be-
pi, but
2 pi over 1.
good. This happens every period, right?
That's
You guys all see that?
Pi.
So I can add 2 pi to this thing.
Okay.
Okay, so maybe I'm removing a little bit of the uncertainty. So I'm going to take the h off of ish here. And I'm going to think, okay, well, maybe it's pi over 6 plus,
2 pi, like, I mean, a variable to oscillate.
oh, good, 2 pi, and then maybe n, right? And I'll let n be, what should n be?
How many variables?
Yeah, so it needs to
How
be
many times you
a,
want to go to?
should it just be
How
a
many times are
counting number or a whole number or
Whole
an
number.
integer?
It shouldn't just be a whole number because it happens every.
You guys want to do n is a whole number? So remember the whole numbers are 0, 1. You guys haven't seen the W before?
I think you
I
said that's
remember
like
seeing
really
it
good.
sometime.
What if I did this? What if I wrote n is n, and then I wrote a list. 0, 1, 2, 3,
Dot,
and
dot, 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 dot.
Is that enough?
Yeah.
Which way does that go? If I keep adding 2 pi's?
Oh, that
You
just
have to go to
goes to the
negative.
right.
Yeah, that only goes to the right. You guys see that?
Yeah.
I want to get these ones back here too, right? You guys all see that?
Could you could you put like dot, 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 and 0, like, oh,
Excellent.
plus or minus, there you go.
So you could do plus or minus 2 pi over n, or 2 pi n, and then you could do this. Or you could do and in, and dot, 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 -3, -2, -1, 0, 1, 2, 3, dot, 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 dot. Or you could write the big capital Z. I don't care. Pick one. But this isn't all of them. So the ones that we have just now are this one, and this one, and the one that's right there. You guys see that I missed some? Yeah, it happens on the downs. Like, I've got it on the down slopes, right? But it happens on the up slopes too. So where's this one? Yeah, that's at -5/6. You guys see that?
So is the whole equation
Yeah, so I need ±5/6, ±2 pi n.
Is there a symbol for natural numbers?
Yeah. So, yeah, I personally would write this as ±5/6 plus 2 pi n with n in z. That's how I would write it. You guys can write this any other way that's equivalent. You guys cool? Got all the answers? I'm only pretty sure. Right? So I think those guys cover the,
right hand side possibly?
yeah, the ones on the down slopes.
Yeah.
And these guys cover the ones on the up slopes. And I'm pretty sure that's all there is. You guys see that?
Yeah.
Like, it seems
Does that mean
like,
should
yeah, there's
oscillate
these
the
guys,
exact
and then there's those guys again, and then there'll be those guys again, and those guys again. And I got the ones going backwards, so I'm pretty sure on this.
Pi plus minus pi/6 covers what? The
So-
upslopes?
The plus pi/6s
Uh-huh,
are the ones on the down slopes,
okay.
and then the minus pi/6s are these ones, the one on the up slopes.
Alright.
So I think all told, I've got all of them. That's cool with that? So it should be noted that solving things like this gets a little nasty, and you really maybe want a picture to try to tease out exactly where everything is. Cool. When could this have less solutions than this whole bloody mess?
If it's restricted.
Yeah, if there's a restricted domain, or if there's some kind of good reason that you think the angles have to be within some certain space.
Like real life?
Yeah, exactly. Like real life. Perfect. Alternatively, right, if I hit just barely the tops, I maybe wouldn't have to worry the plus or minus here.
Oh, you're trying to get like a tangent line or something to
Yeah, like if if I was looking at the tangent line, like if I had 2 cosine theta equals 2, right, then I'd just have to go find the peaks, and I wouldn't have to worry about the plus or minus on that first guy. That's all good with that?